Hello, and welcome to Chapter 8. We have two recordings. This is recording number 1 of 2, and Chapter 8 is about scheduling resources and costs. So resource scheduling and costs involves, in one sense, a linear process where you look at the scope, the network, the resource and cost scheduling, and the master plan all comes into the risk. What is the risk to the project? So we use the resource schedule to assign time-phased costs to provide a budget baseline. So time-phased costs. And a time-phased baseline is a cost baseline derived from the work breakdown structure and the project schedule. And the budgeted costs are then distributed to marry the schedule. So what's happening and what's it costing? And time-phased budgets are basically planned costs broken down by distinct time periods for a work package, not the entire project. It provides better cost control, and these, of course, are then reviewed at your milestone project meetings. So when we look at the resource problem, we have resources and priorities, and always in contemporary any management, there's the decisions about allocation. So project network times are really not a schedule until resources have been assigned. So they have that second dimension. And the implicit assumption is that resources will be available when in the required amounts, when needed. And you think, well, yes. However, as we know, there's always scarcity. Adding new projects or new components or new activities always involves making realistic judgments then of the resource availability and the project duration, and whether one brings about a change in the other. And we look at that in some of the worked examples. And cost estimates are not a budget until they've been time phased, because it's time, of course, you cannot change. Budgets you can. Resource smoothing involves moving and leveling out the varying demands on resources by using slack, which we've looked at, delaying non-critical activities to manage resource utilisation when resources are adequate over the life of the project. So smoothing is varying demands by using slack if you've got it, which is why it's always important to identify slack. And resource constrained scheduling then is the duration of a project might be increased by delaying the late start of some of its activities if resources are not adequate to meet peak demands. In one sense, that's fairly intuitive. If you don't have the resources, you can't start things until you've got them. And then, of course, that becomes a late start, which then turns into a late finish, unless, of course, you have a fair amount of slack in that activity, which you can call on. So types of project constraints are basically technical or logic constraints, things that simply can't be done because of the order in which they're in, constraints related to the network sequence. Physical constraints, activities that can't occur in parallel or are affected by contractual or environmental conditions, weather, rain, space, that sort of thing. And resource constraints are the absence, shortage, or unique interrelationship and interaction characteristics of resources that require a particular sequence. And it might be in terms of, plumbers can't be in until this has been done, or painters can't come until plasterers have been done, or this module can't be added to your network until that's been done. So resource constraints. So the resource constraints are basically people, materials, and equipment. People, materials, and equipment. And there's some good examples there. Technical constraints around, if you're looking at a project, starting, pouring, framing, roof, end. That's building something. Start, design, code, test, end. A network project. The other constraints might be around activities, the resources, or time. So when you look at scheduling then has a number of challenges in it. You need to identify what the problem is. And using a priority matrix will help you determine if the project is time or resource constrained. Got all the time in the world, but not enough resources. We don't have enough resources. We don't have enough time, but we've got plenty of resources. So do we change what we're doing? The time constrained project must be completed by an imposed date. Resources are flexible. Additional resources are required to ensure the project meets schedule. So it's basically throwing money at the project. Resource-constrained projects in one in which the level of resources available cannot be exceeded. Resources are fixed, time is flexible, and inadequate resources will delay the project. Resources here being people, materials, and equipment. There are some limiting assumptions. You can't split activities. Once an activity is started, it's carried through to completion, and the level of resources used for an activity cannot be changed. And there's some assumptions that we use in project management, which invariably get fed into the software, which are built into it. The risk assumptions are that activities with the most slack pose the least risk. Reduction of flexibility does not increase the risk, and the nature of an activity does not increase risk. So these are assumptions that would need to be tested before you started to move resources around. Time-constrained projects must be completed by an imposed date. They require the use of leveling techniques that focus on balancing or smoothing out resource demands, and some good examples in the text which we'll go through. If you use positive slack, you delay non-critical activities to manage resource utilization. And that's why possibly when you're putting together a project, you might, with a bit of experience, start to make sure that there's a fair few non-critical projects which are spread through the project in such a way with slack that they can be a source of resources. Peak resource demands are reduced. Resources over the life of the project are reduced, and fluctuation is minimized. So basically, what happens in periods of shortage? Now, there's some pros and cons here over resource demand leveling techniques. The advantages are you reduce peak resources. Yep. You reduce over the life of the project, and the fluctuation is minimized. So you basically, in a way, you could possibly reduce the resources available in your project. Well, everything's going to be reduced. The question then is, does the project meet time and quality standards? The disadvantages are you get loss of flexibility. If you reduce the slack, you don't have the flexibility to move activities around. And with experience, you realize that slack sometimes can be your friend. And it increases the criticality of all activities because there are less resources to go around. And generally what happens is there's a trade-off in the risk. And there's a good example here, and both of these examples are from the text, so I won't go into too much example, but this is where you're looking at the botanical garden. And what we're doing here, there's a number of backhoes needed for particular activities. And what we're trying to do here is use some smoothing to reduce resource demand. And you see that the various activities there, design, layout, walkways, lighting, etc., each have a time when they start and the resources. And clearly, the resource constraint there is we don't have enough backhoes. We have demands from in periods 4, 6, 8, and 10 for 4 backhoes. And I think the constraint is that you may only have 2. So what you've got to do, you've got to, or 3, sorry, you have to move them around. So you reduce the peak number from, on the second diagram, on the second example there, from 4 down to 2. But what you've done is you start to move the activities around. For example, 14 and 16, you're starting to move the number of backhoes around so that you move them from the peak, which is in period 6 and 8, and you smooth them out. And I guess intuitively, you move what you've got around, and you may need to change some of the activities. And there's clearly some slack in the system here that you've taken up. The middle chart shows the resource profile for backhoes, and for periods 4 to 10, 10 backhoes are needed. And because the project is time constrained, the goal will be to reduce the peak demand for resources and increase the utilisation of it. So if you, of course, are hiring these backhoes, you'd be wanting to get the best use out of the minimum number. And what you've done here is you start to look at some of the activities. You look down the side, say design, layout, walking, lighting, and working which of these provide the best choice for smoothing the resource needs. And I think they've identified, fence and walls. They're the things that you can reduce. So overall, in this example here, where you identify the activities that can most stand the reduction in resources, you're able to smooth out the resources over the life of the project. And the important point is that the resources needed over the life of the project have been reduced from 4 to 3, the backhoes from 4 to 3, which might be a saving in lease costs or rent costs for backhoes. So the objectives in this exercise were to reduce the peak demand in periods 4, 6 and 10. The number of resources has been reduced and the fluctuations were minimized. So when you look at the smooth example there, much more consistent number of backhoes and not big degrees of fluctuation, which of course from a project might mean you don't have backhoes that are sitting idle, or you don't have backhoes that you have to move to another project, which might involve additional costs. Now, so who thought building a garden could be that simple? The next example probably is a bit more complex, and it really possibly you should look at this when you look at as you're going through the text. And the resource constraints here, well, the trick really when you're looking at these resource constraints is to prioritize and allocate resources to minimize delay without exceeding the resource limit or altering the technical relationship. So, you've got a fair number of constraints to be dealing with there. The details here, and there's quite a number of charts, and I would really recommend that you look at the commentary in the text. But what the text does, it takes you through the examples. For example, in periods 0 to 1, this is a programming activity, which is what the P stands for. P stands for program, and we're not talking about backhoes anymore. And we look at the resource load, and we've started with 2, 2, 5, 5, 4. So the issue here is to effectively manage the resource load for programs. So the commentary in the text here indicates that the programmers are limited to 3. So what you really have to do here is smooth out and minimize the peaks in the programming over the period of the project. So the commentary here is when you look at figure 8.4, and in the text, it starts to identify the activity diagram, then the resource load chart, and how they are amended. But with the program is limited to 3, you can see how, just from me flipping through, we then look at activities in the diagram 8.4, where it shows you how the limiting to 3 program is starting to delay the project. So you need to reschedule where they're placed. So if we then look at here, so we've now started to reallocate the programmers and indicated where the slack has been taken up. So we've got the resource contained schedule now goes through from periods 2 to 3, and then we start to move the resource constraints through the succeeding periods. Let's have a look and see what happens towards the end. So we can see what you're doing. You're starting to move the early start and late finish times around. So you're starting to move the timing of the various activities. And what you're basically doing is starting to push it out a bit more, but also smoothing out of the resources. But the resource available, it continually shows you that you've now leveled, in a way, you've leveled it to 3 rather than the peak of 5 before. and then you end up with a new resource constrained network. And it's interesting where you look at the combination. We look at the first one. This is the interesting one here. This period here where you've got 12 is the early finish dates. And when you look through here, it's gone from 8 to 12. Well, simply what it simply means is taking it from the text, it basically says that if you compare the slack for each activity found in figures 8.4 and 8.5, which are in the text, the slack has been reduced significantly. Point number one, take the slack out. Activity 4 has only 2 units of slack rather than what appears to be 6. So you've found quite a bit of slack there. And this occurs because only 3 programmers are available and they are needed to satisfy the resource requirements of 2 and 5. So what's happened is resources have been moved from where they're not being used. And it says, note the number of critical activities, 1, 2, 3, 4, 5, 6, and 7, has increased from 4 to 6. And basically, what it shows you, you can move the resources around, but you may also have increased the risk of being late with your project. However, as we know, we go through all of these projects, moving resources, identifying slack in order to meet the constraints we've got. So this is it's an interesting example, and the key is where you start to see the changes made, for example, to the activity diagram where the early starts and early finishes start to move around. So some activities, you need to move their starting time in order to take the slack out of the system in order to free up the resources, which at the end of the day seems fairly intuitive. That's the end of the first recording. So let's now break and go into the second recording.